everyone, this is Alf from Chalk. I wanted to give a quick overview of how you can set up a recommender system within the context of a marketplace. And so usually when you're using Chalk, we start off by doing some domain modeling. And so in the case of a marketplace, we have things like interactions, sellers, reviews, items, as well as item prices, users. And then for the actual Rexus use case, we have these user item pairs where we can extract features from both users and items and then essentially create new features that we use for ranking. And so typically we will import things from our Chalk SDK. We call it ChalkPy. And so if I expand this, let's say I go to review, we can import this features decorator and we just attach it to this Python data class. And then now I can start adding features. And so a cool thing here is that we have some base features like ID, timestamp, review body, and a rating. And then Chalk will actually pull these features from the actual underlying data source, right? So I can add some Chalk comments to the SQL file and say, I want you to connect to this data source. I want you to make this query against this table, and we're going to essentially hydrate this feature class with this data, right? And so if I look at the project structure, I can see that we have a Chalk SQL file for things like the seller, the review, the item, the interaction. And so you can just put those into your project, and then Chalk can automatically pick them up and know where to get that data from. And the nice thing about this model is that this review class might have 30 different features. And 10 of them might come from Postgres, 3 of them might come from ClickHouse, 4 of them can come from hitting some microservice. And so we can essentially fill up this feature class with data coming from various data sources. And so once we have some base features, right, we can compute new ones. So I can say this review is positive if the rating is over 4, right? And so this isn't going to actually be computed until we fetch that underlying feature that it depends on. So we're essentially building this huge graph of all of your features, and then at query time, we can take subgraphs depending on what you request, and then build query plans for that particular request, right? And so a good example of that is I have this pretty simple query where I'm just getting 4 features from this item, and I can essentially arbitrarily add new features, right? So I can say I also want the title, I also want the ID, and then we're going to get more features back when we actually run this. And so the cool thing is that both of these requests have different query plans, right? And so if I have a bigger query, so now I'm fetching 20 features, I can actually see the query plan. So if I click this link, it opens up my Chalk dashboard, and then I can see that we started off with the review, but we were able to pull out features from other related feature classes, like the item connected to this review, the user connected to this review, and then we can use all of these to essentially compute new features. And so this normalized rating, so for example, if I click this normalized rating, and I go into here, I can see that the normalized rating for this review is computed by taking the review's rating and then also using features for the item connected to this review, like the total number of reviews as well as the average rating, right? So we can cross these different feature class boundaries to compute new features. And so that's actually what we can see in the dashboard. And so this node actually turns yellow because even though we're writing a regular Python function, Chalk is actually able to parse this function and then make it much, much faster than it is, right? So if I make this a little bit bigger, I can see that the function I just showed you actually gets turned into these static expressions. That way they're still run kind of as UDFs with a native runtime. So that's how we keep things fast, even though you're writing Python. And then the next thing is that we can define these cross-class relationships by using also the type hints. So I can say this review has an item, and that item is essentially fetched using the item ID. And instead of that being a string, we can actually just point to this feature attribute for this feature class, right? And now that I'm essentially there, I can jump to that feature class. I can see that item has a bunch of features itself. So we have things like a title. We have things like a genre that we used an LLM to compute based on this title. We can also make this data frame of reviews, right? So I can say this item has many reviews using that same item ID, and we can do projections against this data frame to create aggregations or more features. So I can say okay, I want you to pull out this column, the rating column, and I want you to take the mean, and that essentially gives us the average rating across all reviews for this particular item. And we can also make that windowed, so I can say I want you to compute this expression at different intervals. So get me the review count from the past 30 days, 60 days, 90 days. And we can do that by passing in this chalk expression, and then chalk can essentially inject these values into this chalk window, right? And in addition, we can also materialize these. So I can add a configuration. I can do like a, let's see, give it like a cron schedule. I can say like, I want to do this at 3-day buckets. So like in addition to like expressing your features easily, we can also essentially build these ETL pipelines for actually computing them in very in compressed ways that are very efficient, right? And this is nice because then you can see the logic for how this feature was computed along with the actual feature itself. And so you don't have to like essentially go into like AWS console and be like, how does this pipeline work? And then this is version control, right? So you can essentially see at different points in time for your actual ML deployment as to like how this feature was materialized, right? Like a year ago, it could have been 9-day bucket duration, for example. You can just see that in the code. And so the nice thing about these data frames as well is that you can also query for them. So it's like I have, for example, a regular item, and then so these are the features for that particular item. I can also get that data frame out, so I can say like, I want to see all of the prices for this particular item, right? So we can also get these data frames back. And in addition to getting them back, we can also filter them, right? And so I have a pretty good example down here in user. And so this user has a bunch of interactions with a bunch of different sellers. And so if I run this query, I can see that we have a bunch of different interactions, and we can actually filter them by this interaction type, right? And so we have things like feedback, we have things like product inquiries, and we also have things like orders placed, right? So I can pass in this filter and say we only care about orders placed, and I want you to pull out the price. And then if I take the mean for this, I'm essentially getting the average purchase price for this particular user, right? And this can actually be even more complicated than that, right? I can also pass these into other chalk expressions. So this is what a chalk expression looks like. We essentially have this SDK that gives you a bunch of functions. And so I can do like f dot and then call a function from chalk. And then I can essentially pass in more features into this function, and I can also call more expressions, right? And so if I actually jump into the SDK, if I go to chalk functions, I can see we have like, hundreds of functions here. And then all of these are guaranteed to run natively to be super fast. And so actually when we were doing that thing earlier with Python resolver, we were actually just converting that resolver into composable units of these functions. And so another nice thing about these functions is that we can also materialize these as well, or also cache them. And so, for example, I have this max staleness feature, and this essentially lets me say like, if the inputs to this particular function have been seen before, and we're within some time window, I want to save this to a cache, and then I want to hit the cache first, right? And so this is really good if you have a very expensive microservice or API call. So let's say you have a microservice that's like slow or just costs a lot in the case of an LLM. It's like if the inputs to that microservice are the same, we should just use the value that we've seen before. And then we can have chalk do this, for example, within the context of 30 days, I can do like 1 minute if we care a lot about, freshness, or I can also do it for infinity. And so I do this a lot for LLM calls because I know that, the book title is never going to change, so I can just cache it forever. And then another cool thing here is, so I'm able to cache this top genre feature, and then I can do things like approximate top K. And so chalk is essentially saying, filter out this data frame, give me only product inquiries. I want you to fetch this genre feature, which is computed by an LLM for all of the interactions, that match this filter. Then I want to get back essentially the top 10 genres for this particular user, right? So you can do pretty complicated things in a few lines of code. But in the case of our actual Rexus example, we have this user item pair, and so when I do make a query for this, I'm going to pass in both the user ID and an item ID, and then chalk can go out, pull out these other features and say like, what's the price difference for, the most recent price for this item compared to like how much this user normally spends, right? And once I have this price difference, I can, do like a price difference ratio. I can also do like an affordability cap. And typically we'll do this for like hundreds of items. And so I'll give you an example. So I have this Jupyter Notebook, and in this Jupyter Notebook, I can just run it right now. I can say like, for this user ID 50, I'm going to take 10 instances of that user, then I'm going to take in 10 different items, and then I want all of these features back. So I want like the title, the price difference between the item and the user, I want the average rating for the item, and then we essentially get back this data frame. So I can say like, this is the book title, this is the price difference, I can see the price fit, etc. And then typically we can pass in this big matrix into like some other system. Think like Vertex or SageMaker. So this is what a lot of the Rexus use cases look like. It's like us doing book queries between like user item pairs or user seller pairs, etc. And lastly, we can also do a ton of things with like vectors, right? If you want to essentially augment some of your systems with like vector search, or if you're doing things like RAG. And so, for example, I can say like, okay, we have this review search. So given some query, I want you to run an embedding on the text that's passed in. And so in this case, like this Q query is going to be embedded using Vertex. We're going to use this particular model. And after we do that, I'm going to get a bunch of results back after hitting like a vector database, right? So if I actually jump into like this feature, this review document, I can see like this, let's say go to LanceDB. So this is like a regular Python resolver, but we call this vector database. And what I can see is we're going to take in this vector, we're going to take in this query, and then we can actually execute a vector search against this database, right? And then we can create a bunch of review documents that we return as a data frame, right? So our whole goal is to just give you a bunch of primitives that make it really easy to do any type of use case that you want, whether it's Rexus or search or fraud detection, etc. So we just want to be a general platform that guarantees, very low latency, high scale infrastructure. That way you can abstract away those challenges and just think about how to design features well and then build models more quickly. Yeah, so that's a quick overview of Chalk. Hope it helps.